Hello and welcome. My name is Lauren Harder, and I am a senior educational developer here at VEX Robotics. And I have the pleasure of having here Dr. Jameela Jaroodi with us from Robert Morris University. She is a software engineer and also a professor of software engineering there at the university. And we are so excited to be able to chat today about engineering, more specifically with Engineering Week coming up here, and to talk about a little bit about what that means as far as engineering goes, and Dr. Al-Jaroodi's experience here in engineering. So if you don't mind, Dr. Al-Jaroodi, if you could kind of let us know a little bit how you got started with engineering in general, or was it something that kind of sparked your interest at a young age, or how you got interested in it?
Hi, Lauren. It's good to be here. Actually, I'm a computer scientist by training and by early career steps, but I got into engineering mainly because of the software engineering area. And I had interest in computing from the very early ages. When I was very little, computers were not very common, but I was lucky to get exposed to the use of computers, and I got hooked ever since. And eventually I decided I wanted to be a professor, so I followed through the study path all the way into a PhD in computer science. And then I worked in different computer science departments until I got here to the Department of Engineering, and working as a professor of software engineering here.
Awesome. Now, if you could, I know there's many different types of engineering, and there's also different things that go into computer science as well. For those that are not super familiar with both what computer science actually entails and what software engineering is,
Mhm.
would you be able to shed a little bit of light on what those two kind of different fields are?
Okay. Computer science and software engineering kind of like complementary fields. In some ways, some would look at them as the difference between science, like in physics and electrical engineering, for example, where in the science we cover the basics, the theory, and proving how things work, showing what's the best way to do things. And then in the engineering side of it, it's like applying all of this to actually solve real life problems. However, in computer science and software engineering, that line between the two has blurred a long time ago. And a lot of computer scientists do a lot of software development. A lot of software developers work into the underlying base theoretical areas. But overall, it's all about being able to translate real life problems and create software-based solutions that will handle them for us.
Oh, awesome. Now, if there is there a particular event you would say, or maybe a project that you've done in your career so far that you found maybe the most rewarding, or anything along those lines, whether it's when you're a computer scientist, you were saying before, or now as a professor, is there anything that you could maybe share about some of those different projects that you may have done?
Um, I've done plenty of projects, but one thing that stand out is when I was doing my PhD, um, we had a class in advanced computer architecture, and we were required to write um, parallel programs that can solve problems across multiple processors so that they can do it faster. And my work partner and I decided, okay, instead of just writing a program to solve a specific problem, we said, okay, let's do something for a different language that does not support parallel programming right now and make it support parallel programming. And that was like this spark that actually got our class professor to hire both of us as research assistants and expand this into a full-blown research project where we actually created a parallel Java version that allows you to write and execute a parallel program across many machines, even if they're not the same machines. And that kind of was a big highlight on where I was going. But beyond that, when I got into actual in academia, I see my accomplishments more in in the realm of actually being able to work with students, create new projects, no matter how small or big they are, but seeing how they progress and how they do their work and succeed in that. And that's, I think, even a bigger rewarding thing that I do.
Absolutely. I know from my experience myself, I come from a high school classroom environment and then also the collegiate, and I can say that it's been, so rewarding being able to help students, especially work on different problems with them, and then they go through and solve them, and they're just beyond ecstatic, and
Absolutely.
being able to kind of facilitate that and be with them along with that journey has been really exciting. So
It is. It is absolutely.
I think that's fantastic. Now, what would you say are some of the different maybe skills or things that you would recommend for someone that's interested in the computer science field or software engineering or maybe both? I know from our end of VEX Robotics and kind of dealing with, not only the robotics part, but also the different coding aspects that go along with it, things like iteration and definitely problem solving and perseverance. What would you say as far as, kind of those skills that lie in those different fields?
Um, I think the most important thing, as you just mentioned, is being a problem solver, being creative, and how you look at a problem and break it down into multiple parts. I think one of the most difficult things I see students struggle with is looking at a big problem and trying to figure out how to pull it apart so that they don't have to think about the whole thing as one unit. And I think this is one of the most important pieces of information, skills they need to build. Another thing would be communication. There's a big misconception that computer scientists and software engineers are loners and they work alone, and that's absolutely not true. Most computing and software projects are team-based. Teams would work in small to large numbers. Some teams would be even run into the 20s, 30s of the members, and they have to be able to work together, to communicate, to collaborate, and to schedule work and resolve conflicts and do all the teamwork things that they have to do to get the work done. And I find that to be an absolutely important skill.
Yeah, I couldn't agree with you more. I know that we've hosted different robotics teams out of our office here, and in general, VEX has, one of the largest robotic competitions in the world. And a lot of times, different parents or teachers or even students themselves will ask me, well, what is it that my student or my child has to know in order to compete and be able to do so successfully? And it's not just about the building or the engineering. It's not just about the coding. It's the whole experience, being able to build something and collaborate, go through that engineering design process and iteration, and then being able to, like you said, that cooperative, that teamwork, being able to share ideas and things like that as well. So I think that that's really great to bring up, because I think a lot of people, especially as you mentioned before, think that a software engineer or computer scientist kind of do their own thing. But it is dealing with a lot of different collaboration as well. So I'm definitely glad that you brought that up. Now,
And another thing that comes to mind, actually, I usually ask, especially when I meet with prospective students, and they ask about the field and computer science. And the one thing that I usually ask them to do is take some time and try to learn a programming language, any language, as simple as Visual Basic or Python, and do a couple programs and see how you feel about it. Because I know that I've seen people who are really good in programming and they can do a lot of nice things, even learning on their own. But at the end of the day, they would come to me and say, like, I know I'm good at it, but I don't see myself in it. I don't want to see myself doing this day in and day out.
right.
And I tell the prospective students to think about that and kind of let them, in a way, guide them on whether or not they want to go into this field. Because I've seen this in my own boys. One of them was like computer science through and through. The other one tried it for a little bit and says, like, I really can do a lot of nice things, but I don't want to do this for the rest of
Yeah,
my life.
right,
So,
right.
it
Yeah,
it makes a huge difference. The personal preparation, I think, to it.
yeah. And I was going to ask you too, and you already kind of, I think, answered part of it was for someone that wants to know more about the field or kind of what it's like to get into computer science or software engineering, you recommended trying a programming language. And I think that's really great advice because why not try it yourself? You know what I mean? And I
Well,
would say too, I think that a lot of people may feel intimidated, not just by the field, but by coding in general. And I think that your advice to try the language is definitely helping with that as well. But what would you say to someone that thinks that the field or in general computer science or programming may be intimidating? What would your advice be about that to maybe let them know that, hey, you can try this too. You can definitely investigate it a little further or things along those lines.
well, honestly, what I would say is anything you don't know is intimidating.
Good point.
So the first step is to get to know it. And this is why I usually ask or tell prospective students, like, just go in and pull a few tutorials online about some programming and look into it and see how you feel about it. As soon as you start learning a little bit and looking into what goes into the process, I think that factor of being intimidated drops very, very quickly. And you become able to think about, okay, now, would this something I want to do or not, regardless of whether it's intimidating or not? Um, Generally, my motto is life is tough, no matter what you're doing. So you better spend it doing something you like.
Yeah, absolutely. And I think that's great advice for sure. I think we'll end with one last thing that I wanted to ask is basically what does engineering week mean to you? And to me, I would say it really sheds light on the field itself. And not only that, but also like you mentioned, kind of answering questions that people may have misconceptions, either about the field or kind of what it's like to be either a computer scientist or a software engineer, and kind of give a little bit more understanding because like you said, people may not know what they don't know, and that may be intimidating to them. So for me, it's, kind of shedding some light on that career field and really bringing engineering to the forefront because it's everywhere. It's in everything that we do. So that's kind of what it means to me. But what would you say kind of engineering week in general means to you or the kind of the field of engineering?
Well, I think it's one of the major thing about it is it's an opportunity to get students and prospective students in general and high school kids to basically get a bit of an understanding of what engineering is all about, what they can and cannot do as engineers. And I think creating those connections with people who are already in the field is pretty important. What I hope it will be about is helping students see that it's something they can do and that they should at least consider doing, if not at all going all the way through with it. But it's just that removing that misconception that it's hard, it's not easy to do, it takes a lot of work, it takes a lot of time. And as I said earlier, anything you do as a newcomer will be hard and it will take time no matter what it is. So I think this is one thing we need to kind of aim for.
Yeah, no, I agree with you wholeheartedly. I think it's more so like you kind of mentioned is like bringing awareness, kind of shedding light on it a little bit more and letting people know, hey, this is achievable. This is something that you can actually try. And as you mentioned, even if it's something that you end up not wanting to do, at least you know
Mhm.
that you can do it if you wanted to. So I
Yes.
think that's a really good way to put it as well. So but I think that's pretty much everything. But I wanted to thank Dr. Jameela Al for being with us. Thank you so much for taking the time. And I know that we are both very, very excited for Engineering Week, and we will see you next time.
Well, thank you for having me. I appreciate it.
Thank you.